where are all the other people. It's hard to begin because we still have so few people over here. So maybe wait a bit longer. So last time we were talking about the surveying, and uh, is the link working now? Which link? Yes. So if you still cannot log in, please respond. Maybe you have some problem for connection. And by the way, class leader to record whatever we teach in video every time. So maybe he can upload the video to some servers, and then you guys can just log into the server and fetch the video. Maybe it's easier. Or if he is convenient, then he can just send you guys the copy, or maybe post copy over WeChat. But WeChat, I think if you post over WeChat, you have a limited the file size. So you can't hear my voice or no sound. Mark, you can't hear my voice. How about others? Could you hear my voice? I want to make sure maybe some of you, you probably didn't turn on your microphone or something. So the majority, if you can hear my voice, it means that some of you have some problem setting up your microphone or something. So try to figure out. Yeah, so if someone can hear, it means in my side, there should be a problem. So the problem might lie in your side. Okay. So so far we have 20 people, and maybe we keep on chatting for some time, and then when people reach half of people, then we can start our class. It's better you guys can join the class in time. Otherwise, because online the teaching is very slow, because it's hard to explain in Blackboard. So a lot of things it takes. If I want to explain something, it might take just a couple seconds to explain in Blackboard, but to explain online maybe takes 1 or 2 minutes. So it's not so efficient online teaching, but so it's better you guys can log in time, and then we can have you can proper learning. Otherwise, you just learn a little bit, and some of you don't log in, then you can't even learn anything. So by the way, I probably have to talk about the scoring as well. If supposedly probably we haven't decided yet. Supposedly I ask you guys to write essay, then essay will consist of 60 to 70% of the whole scores, and then you have the other 30 to 40 scores percentage that might come from your attendance, your homework, and also the most important one, online one. Because in the class, I can see you guys. I can see your face, your face expression, and I can ask you to do the on-class homework or something. But since online, I don't even know where you are now, and whether you are listening or not. So the best way for me to check is from time to time, I'll just ask you to do some online interactive exercise. So just write down the results and post on the WeChat, and then I can easily check. And then I have a copy of your attendance as well, and then I can give you some proper score for your performance in class. So is that clear? This bit previously is not so important, but now it become very important, because otherwise I don't even know your performance or how you proceed with your learning. So that's probably the best way. Just like after a while, during the teaching, I'll just ask you to do some exercise, and then you give me some feedback. Write down the calculation or the results based on what I teach you, and then I can give you some proper score. So it's not only about attendance. I know some of you don't even attend, and then in the end, probably claim you attend, doesn't claim contribute too much. So I will rely much more on the your in-class interaction. Is that clear for you guys? Hello, are you guys still there? Hello, hello. Okay, very good. Okay, so we can't keep on waiting. We can't keep on waiting. And by the way, if the class begin and you check in, it takes too much time for you to check in or something. We will regard you absent as well because you might just 10 minutes before the closure of the class, then you log in. Then in this case, we don't count you participate in this class. So please join all the time since minutes 1 till end of class. Okay, without further ado, let me start to look at the our lectures. So previously I was talking about how to do the surveying. So the first step is that you have to focus on errors. And you might wonder why error plays an important role. Because for one thing, your measurement, the tool used, is not very accurate. So you need some statistics to assist you in produce some much more persuasive result. So that's very important. So as a surveyor, probably half of the time you need to collect to the statistics as well. If you are really a professional surveyor, not only just look at the tools and do the measuring, you also need to have some mathematics and statistic knowledge in order to complete or produce a persuasive result to your clients. If your client might ask you to do surveying for him to measure his land or measure some from some position or something, and in this case they pay you, but they want to make sure they pay you properly. So you might think maybe he just 0.1 meters difference is not a huge matter, but sometimes it matters a lot because depends on the property itself, and it depends on your client. So you cannot just you just treat as it's not your land, so you just think it's not important. You must take it seriously, in particular for the errors. Okay, let's take a look at today's book. Not today's book, our textbook. So we'll follow suit for the textbook, and for the important bits, I'll pause, and for you guys to do some practice. So this book, you need some practice as well, because some of the statement in this book is a bit like too formal, but we still need some exercise and practice. So I'll try to follow this book, and then we will discuss. If you have any problem, just raise your problem, then we can discuss. So chapter 1. Chapter 1 is about errors. Last time we talked about errors in measurements. So basically, the section 1.1, let's go into the section 1.1. So what does it mean errors? Error means that you have to, based on the statistics theory, you have to tell people, or your client might tell you what kind of tolerance they can tolerate. So based on their tolerance, you have to calculate the error as well. So there are two parts. One part is the error might come from your professional judgment. How much error you're supposed to put based on this machine. That's the professional one. The other one is from your client's perspective. He might want you to calculate or do some error measurement for him to understand how far the data from the accurate one. Okay. So last time we talked about something called systematic error. Systematic error we already discussed is about your system. So this error last time I call it internal error. Why? Because it happens basically is connect to relate to your systems. So system in your surveying it means pretty much it means the machine. So the machine itself have some errors. You might think how come? It's easy to understand. Machine itself easy because if you want to if you use a laser, then it's much more accurate. But the thing is, it's much more expensive. So even in laser have some errors as well. So error might come from the way you set up the machine, the way you operate the machine, and the age of the machine. As your machine might be aging as the time goes by, and then it may become less accurate as well. So all sorts of things, or maybe your machine run out of battery is also might cause some systemic errors. So the other one is called random errors. So random errors in this case is much more related to statistics, or it's called accidental errors. So in this case, since it's called random, it means that you can't easily predict in advance. So it means you don't even know what the error might lie, or when the error might occur. This kind of situation. Unlike the systematic error normally is already written on the machine. Sometimes they'll tell you how accuracy the machine is. It probably is plus and minus 2% or something. This is called error. So you can easily tell from the systematic error or do the calculation. But for the random error, it's hard to tell. It really relied on the static speed. So it's random means it's related to statistics. We'll come to the speed, how to give people some result about this random bit. So random in org is called accidental errors. So where does this bit play? Last time I told you guys is about like the weather outside, the temperature, the way you set up the level, or the way you set up the stuff, the way you hold your tape, and so on and so forth. So all these will cause some random errors as well. So it means it's unpredictable, or you don't even know it's already an error. So in this case, you have to consider about these two errors. One is called the systematic error, the other called random error. And then later on, you have to put these two errors together to generate, to fully consider what we call gross errors. So some error might have a positive inference, and the other error might have a negative inference. So cancel out. Maybe you still get a very precise and accurate measurement. So it's hard to tell. It all depends on the. Let's come to the 1.2. It's called probability distribution. This one basically is related to your error, and you might wonder there is a delta y here. Delta y means it's a result. If you take the result for a measurement, this is a delta y is an error. You can treat as an error. So this error related to the delta x. Delta x is something, it might be random in here, because normally related to the probability is related to the random one. So this random error, you can, it depends on, for example, the wind, the strength of the wind, or the pressure of the atmosphere or something. That will influence directly decide this delta x. And this dx, according to this error, if this error is randomly happen, but strictly follow the pattern of normal distribution, then this dy can also be calculated. And in some sense, they can also be predictive. Of course, this kind of predictions are very accurate because it's based on probability. So this kind of calculation normally in your writing or when you producing your measurement to your clients, normally on the writing you have to say we are confident based on probability. This error is how much. You will have this kind of wording because you have one assumption here. Well, the assumption is this error will based on normal distribution, or we call Gaussian distribution. Gaussian is the German guy, the German people. So he's doing something in surveying as well, because Gaussian is probably the best mathematician in 19th century. But once upon a time, he was doing surveying for their country as well. So some of the probability theory come from surveying. So this surveying field provides some mathematics stuff as well. So this is very important one. It also provides some background knowledge for the statistics. Okay, so this is a normal distribution. So you can imagine normal distribution will look like this one. It's hard to draw. Let me try some lines or something, or maybe this one can work. Okay, so normal distribution, you know normal distribution, it more or less look like this one. I can, because more look like this one. So, of course, my plotting is not beautiful and it's not very accurate because I'm using some tool as well. So it's not unlike writing on a paper. Anyway, you can tell in the center one, the probability. So the we call this y-axis. This is your y-axis. I mean the reference. Your reference is this one is called y-axis. Y-axis basically is about your probability. And how about the x-axis? X-axis depends on your we call random variable. Here x means is the arrow. So it means the chance or the probability of happening arrow. You can see is more or less centralized in here. So in this case, if your arrow is here, plus normally we have a plus one. We call the one distribution or standard deviation or two standard distribution. You can tell the most of the data the probability lies in the center. So we have probably it's called, I think it's almost 68. 68 you have one deviation lies the 68 probability percentage lies in one standard deviation. One standard deviation pretty much is between here to here. Between here to here. So in this case, in something between this probability, you have like 68 percentage. If you have two sides is a two standard deviation, you have almost 97. 97. You have this one. This size is a two standard. We'll come to what do I mean standard deviation, but just let you know. And then you have three standard deviation. You cover almost 99.7 percentage. Almost everything is covered. So this is about the arrow. So you have a small arrow that influence dy here is the distribution probability. So if you do the integration, you will get the probability between the arrow which side to if the arrow happen here in this place. What's the probability? If an arrow happen here to here, what's the probability? So you can calculate the probability. On the other hand, based on the probability, you can also refer to the position or the interval, the probability. The arrow might lie. The arrow might lie between these two lines. If the client asks for 68 percentage, if client asks for 97% is over here. So we'll calculate this bit. Just we'll come to that bit later. Okay, the next one. You have something here. It's called true value. What do you mean true value? True value is a fixed value. Here. Indeed, it's quite intuitive. You don't have even look at this one. So true value just means that if you, let's say you want to measure from here, from my position to your position now, how many ways I can do? Nowadays, because you are so far away, maybe you are in Pakistan now. So there is no way for me to use tape from here to your position. So there is no way. So the best way I can do probably I use the GPS. GPS. I locate the longitude and the position of the from the GPS location, and then from the location of you in Pakistan, then I can calculate based on mathematics, of course. I can calculate the distance between me and you. But now, so there lies a true distance. True distance means the true distance between me and you in Pakistan. That's a true distance. But is it possible we get a true distance? No, no way. The true distance, who knows? No one knows. Because how do you know it's the truth? Because for one thing, it's keep on changing. My position and your position keep on changing. How? Because the Earth is keep on rotating. So since the Earth is keep on rotating, and we have some gravity outside the Earth, so the distance between me and you keep on changing. Although it's minor one, very very minor one. So you can easily spot the changing. So what I'm trying to say is that if there is no way, no single human can know the true value, no way. So if someone claim the true value of the distance, the 2 point the distance is how much, then the claim is I think it's just floating. It's claim too much. All right. So in this case, then how am I going to do? True value is unknown. So how am I going to do the measurement? So based on the we call the error. We have to consider about error. So here you can see epsilon. Epsilon equals x minus tau. So the true value is tau. The true value. So what is the x? X is your major quantity. So this x is your major quantity. Okay, and this tau is your true value. And I just say there is no way to do the true value. So it means that this error, there is no way to exactly know this error. No way. If you know this error, it means that if you can truly know this error, it means that you can truly know the true value. But the thing is that no one knows true value. So this error, sometimes people call it true error. But here, it is just an ideal one. Assume there is a true error exists. And then we try to approximate, do our best to reach this true error. So that's the basic idea. So if you want to reduce error, you try to reduce true error. But the thing is that you don't know the true value. So how are you going to reduce to true error? So the way you can do is you try to reduce your tools, your technique in handling the value, the error. Okay, so let's continue. And you can see, so you can have the true value of the true value of the major quantity cannot be decided. You see this point. So the exact value of epsilon cannot be found out. So that's the point I make based on this one. So it means there is no way I can decide the true value of the major quantity. So you can measure it. Of course, you can measure it. But you see on your measurement doesn't mean it represent the true one. It just represent the measurement based on your machine. But it doesn't mean your machine can 100% capture the truth of between the objects. Okay, so what are you gonna do now? Since you cannot have the true major quantity, this major quantity. So this major quantity means that in this case it means it's a real one, a real major one quantity, and this is a. But you cannot do the real major one. It means you always have some description between the ideal major quantity and the real major quantity. So ideally, if you measure in this machine, you can get a result. That will be the ideal major quantity. But the thing is there is no way you can reach the ideal one, and there is no way you can know. The don't even know how to get the result. So in this case, how are you going to? It's just based on your naked eye. So what you can do is you can estimate this x, estimate the potential, or you can the ideal major quantity, the best performance of the machine. So in this case, you have to use your naked eye. This x hat, you have an x where a hat. So this x hat is called what? It's called the most probability value of tau. So this x basics based on the tools, based on the this there is a true x. You can't really get this true x. This true x, you might say, this is basically concerns no human. Because once you use a human to do the observation, you have mistakes lies in between. Because how you read the thing, how you set up the machine, blah blah blah. Too many things you cannot really get the idea major quantity. So if the machine can measure by itself, let's say if your machine can measure by itself, then maybe we can call this major is called idea major quantity. There is no problem. But since the machine cannot measure by itself, machine have to rely on human to do the measuring. So then it become problem. So this X height basics connect with a human. With human, maybe we use a naked eye whatsoever, or use some other observation or something. So this X height basics rely on human. So everything rely on human, you have a chance to make mistake. So this X bar is called the most probable value of tau. Although it's called tau, because why it's called tau? Because if this one is a major quantity, I mean the ideal one, is very, very, very accurate. So accurate that can even reach the true value. Then in this case, this true error can be reduced to zero. Why? Because this measurement can easily get can capture the true value 100%. Then there is no problem. But in this case, normally it's impossible. One thing, we don't even know the true value. That's one thing. I mean, it's possible in a sense like beyond humans' comprehension, because human don't even know the true value, tau. And we don't even know if without human interception or the interruption, the result purely come from the machine. We don't even know. There is a principle in physics, in quantum mechanics, like whenever you measure a machine, whenever you look into the machine, there is a mistake from the machine. So it's called uncertainty observation. So even in physics, they explain this one as well. So remember one thing. The measured quantity means the ideal one. No one knows. So this one, if this machine is good enough, they can very accurate approach or reach the true value. But now these two indeed are all unknown. The true value unknown to human, and the ideal major quantity also unknown to human. So this error, true error, is also unknown to human. So the best way we can do is use the because you can't use you don't know the ideal major quantity, but I can rely on our human eyes and interaction between with the machine. We can generate some X tau. So that's the idea. Okay, so here is very important. I got to always remember one thing is that what you measure is all not true one. It doesn't mean it's absolutely it's very unreal or something. It just means it's not so true related to the true value, but it still you can still approximate the true value. But you must calculate the estimate the error. But now you might raise another question, sir. If I don't know the true value tau, right? Then how do I know the error? That's a good question. You don't know the tau. So how am I going to know the error? The error will based on the probability over here. You will assume this tau basically have a distribution. I don't know the exact one, but I have tried to assume that have a probability. This tau this epsilon, not tau. This epsilon have some probability distribution. So I can, based on this assumption, so this epsilon might lies in the, we call median. By the mean, you call mean, might lie due to mean with the highest probability. So that's the basic idea. Have some knowledge to do assumption regard with this epsilon. But whether this assumption is absolutely true or not, just like I said, it's an assumption based on statistics. Since this one is unknown, so whatever this assumption you make, basically, as long as reasonable, it's hard to argue like it's true or not, because you don't know epsilon. So how are you going to tell whether my assumption is true or not? But based on most of the cases, normal distribution is a good assumption. Okay, we'll come to this bit later on. Let's come to the second one. So now you look at this one. We have what? We have one is called x hat over here. The other one is called the x. Here is you have a true x. And this x we call is the major one, I mean ideal one. You can treat this as this one is an ideal one. Ideal one is like based on the best performance of the machine, based on that, and you can get this one. Or even you don't even know the machine, you can have this one. This one, there is no way to know this one. There is no way to know this one. Like I say, this one is an ideal one as well. And so you use x hat. X hat, what's x hat for? X hat for basically is approximate x. So I don't know the ideal quantity, ideal measurement of the true things, but I can use a machine to approximate. So this hat, if you like, you can just regard as an interaction between human and machine, and treat this x as purely machine. Of course, machine can measure by itself. Basically, it's kind of like ridiculous, absurd, because machine basically is produced by human. So in this case, you already produced by human. By human, basically you have some errors installed in the machine cell as well. So, but we just assume this x exists, and then you use x star x hat change as well. Depends on what? Depends on machine. The machine you choose. You might choose machine A, machine B, machine C, just like the same type of computer. My computer and your computer. Let's say if they are same brand, are they going to perform exactly identical? No way. Even to the opening hours, opening time of your software or something, and the age of your computer, they all differ. Even though they produce from the same company, same time, same assembly line, but they differ because there is an error. That's in between. So, well, one thing, the X hat have something to do with the machine you choose, and the second thing, it have something to do with the human you choose as well. So if I pick up the same machine, and I choose A and B to do the measuring for me, are they going to give you the feedback exactly the observation? No. Why? Because the knowledge they have, they all differ. They don't know some. So maybe one of them know how to set up the machine and how to set up the measure the distance, blah blah blah. So maybe he have a higher chance to get something much more accurate. And the other one doesn't know exactly what he's doing. He just follow a book or something. So he may have some mistake or something. Okay, so remember, X hat is the real. We call real. The real, it's hard to write word over here. It's a real measurement. Measurement. It means it's a reading from your machine. So this is a reading from your machine. This is a reading from machine. Okay. And this one, this X basically is called population. Is a population. Means no one knows this one because normally we call this, and this one is called sampling. So if a population there, you just do some sampling in some sense. Not exactly, but in some sense, this way. We all come to this one. And how about V? V now is called residue. You see, V is called residue. We call residue. Or it's called it's relative is placed in the variation or derivation. We'll do the calculation. But this one, this V itself by itself is called residue. And you put all the residue together, and of course you have to square them. You put all residue together, you will produce something called derivation. Okay. So it's very important. It's very important. And for example, take one for example. If I have 10 people to do the measurement, then suppose I know the X. Supposedly, of course, you don't know the X. So how can I going to get this X? This X normally is based on something we call the mean. You don't know this because no one knows this one. How do I know the real life of a machine? No way. How am I going to know the real life of a machine? I can know the approximately the life of my machine, but if you want to buy a machine, they can't tell you this machine is going to last for 10 years. No way. Okay. So this X, since this X is unknown, how are we going to know? We can calculate the mean. Mean of what? Mean of two things. For one thing, you can use the what I call the probability theory and give a mean of this tau. So this tau we are over here. The mean over here have a distribution. Although I don't know the true value of this tau, but I assume this normal distribution represent this tau. So there is a highest chance the tau will lies in here. This is one approach. But the thing is, since the tau we don't know, they calculate this mean also is in vain. There is no way to calculate this mean. So how are you going to do now? You can do is you use what I call the sample mean, because you know this X hat. This is your eye. You can see. So means real means you can use your eyes to see this one. You can use your eyes do the reading or everything. There is no problem. So this mean will become what we call sample mean. And the previous this one, look at give you assumption or give you. This is called population mean. It means population means I already know everything. It's called tau and it's called population. But the ways most of the time you don't know the population. It doesn't mean always. For example, to throw dice or you cast dice. You cast dice. Do you know the population of the dice? Yes. Why? Because the dice. Of course, you can't say 100%, but based on our statistician, they always claim they know the population mean because you only have 6 points. 1, 2, 3, 4, 6 sides, right? Each side have 1, 2, 3 different points. So what's the mean of these 6 sides? Is 1 plus 2 plus 3 up to 6 and divide by 6. You know the mean of each side. Simple. And you regard this one as your population mean. Theoretically, yes, you can do this theoretically, but also it won't give you an accurate true one because the true one depends on the dice. Some dice is in one side probably is heavier, a little, maybe a few grams heavier. So you have maybe 1/billion chance, have a higher chance of the turn up of than the other side. So this tau. Basically, based on reasonable statistics, yes, we can regard it as we know the population based on the statistics knowledge. But the reality itself is hard to tell. You still don't know, to be honest with you. Okay, so so now you have V. So how are you going to read this X hat? X hat you can regard as for one thing, you can read out as a 10 machine. Then, if you're a 10 machine, I want to age major. Let's say I have a point A. A is a position. This, for example, my position, and B is your position. For example, if we are in Pakistan now, B is a position. So assume we use a tape. Of course, it's impossible to use tape. Assume we use a tape from major A to B. So I can give you 10 tapes. 10 tapes. I can give you 10 tapes, right? And of course, I use the same person in order to control try to control the error just within one factors, 10 tapes. So I ask one people to use these 10 tapes to measure do the measurement from A to B. Is he going to produce identical 10 numbers? No. Why? Simple. Because although it's 10 tapes, identical tapes, you claim it's identical 10 tapes. Are they going to produce the identical? No, because the tape have an age as well. It might elongate, and the temperature differs. That also affect the length of the tape. We'll come to that bit. This kind is called physical error. Physical error you can calculate based on physics knowledge or based on mechanic. A little bit of this. We'll come to in next chapter. We'll do this bit as well. So here to as a surveyor, you also have to know some knowledge about the how to this kind called systematic error. And this kind of systematic error, in order to calculate the error, you must have some knowledge about physics, mechanics, some basic stuff. Not deep, but somewhat, some basic one. So in some sense, as a surveyor, you cannot just say, okay, I can operate machine. That's what we call operator. It's not surveyor. Surveyor you have to produce some. Surveyor in some sense, just like I say, Gauss was a mathematician. He was doing surveying before. So survey needs some huge amount of mathematics as well. So okay, so now this guy being given 10 tapes and to measure the distance between A and B. And he is going to produce 10 numbers. 10 numbers. Let's say these 10 numbers is called xi. Xi. Of course, you have a head over here because it comes from the human measurement. You have a head visual measure. So, and in this case, I equals 1 to 10. Okay, you get this one. So now your V you have a 10V. Then your VI. You have a VI. You have a VI. Okay, this is each one. You have some error. This is correlative. It's correlative. Why not? Why is not? It is not called error because in some sense, human you are measuring and you don't know the true things. You cannot even call it an error in this case. Anyway, so X head, you can have 10 numbers of you measure 10 number, and each number you have a VI. VI is your XI head, right? VI is XI head is your real measurement, your naked eye, and then minus X. X here, like I told you, if you know the real population, X is the mean of the real population. If you don't, then X is we call sample mean. And by the way, what time should we take a break? I think I don't. Maybe we should take a break. I need to go to the toilet as well. Are we going to take a short break? Let me go to the toilet for a couple minutes. Okay. Are you guys still there? Okay, let's have okay, 10 minutes break. back at now is 15:27. Okay, and maybe I can play the same music to you guys. Otherwise, you can feel bored. Let me play the music. Okay, enjoy it, and I will need to go to toilet for a little bit.
Stop your crying, it's a sign of the time. Welcome to the final show. Hope you